pi. Okay, 2 to the 4, this 2 to the 4, 4 into 4 16, 3 in the numerator, this will come in the denominator, 16 minus of 3 by 2. Okay, 1 3 is cancelled out, and this is 2 to the 4, 4 to the 8, 8 to the 16, this is also 16, and here we in the numerator we have obtained only pi upon 16, only 2 and 8 is this, 2 to the 4 to the 8, 8 to the 16, pi upon 16, so it is nothing but 2 pi upon 16, difference is 2 pi upon 16, so what is this, 16 cancel out, so this is 16 pi into a cube into 2 pi upon 16. Okay, so this 16 cancelled out. It is nothing but 2 into pi square into a cube. This is the answer here. Good. Very shortcut answer. So 2 into 2 pi is pi square into a cube. 16 cancelled out. This is 3 minus 1, that means 2 upon 16 pi. That value is 16 cancelled out. That is the point. This is the final answer. Okay, so the volume of the sixth question is this. Okay, the volume of the curve around its asymptotes is this much. Simpler one, no problem. 2 pi a square, 2 pi square into a cube. That is the answer. Okay, now let me take the next question. Now question number 7, what does it say? Okay, so question number 7 is, so 7 says, so that the volume of the solid generated by the revolution of the curve this about its asymptote is this we have to prove here, 1.2 pi square into a cube. No problem. Let us check it. Question 7 is a similar type, but answer is given here, so let me check it. Question 7, so that the volume of the curve, let me write the curve here. Here curve is, it is a minus x into y square is equal to a square x is equal to a square x. Okay, about its asymptote. About its asymptote is to prove the volume of the curve of this curve around its asymptote. Around its asymptote is, what is this, 1.2 pi square into a cube. Okay, now in the previous one it was 2 pi square into a cube. It is 1.2 pi square into a cube. Let me check. Okay, so here the same type of question, but asymptote will be at what point? So here in this case, asymptote is at x equal to 0, because y square is equal to a square into x upon a minus x. So at x equal to a, this is infinity. So at x equal to a, y is equal to plus minus infinity. It means at x equal to a, again the asymptote is this, and here it is only a. So this is x equal to a0. X equal to a is the asymptote here. Y is plus infinity and minus infinity. This is the curve here. This is O, x-axis, y, and y dash axis, x dash. Okay, so this is x equal to a. Now again, I have to take here. Let me take a strip. This is P, Q. I'm sorry. Q we take here on the curve. This is Q here. This is P, M, let me take N. This is the strip here. Coordinate of P are x and y. If I draw perpendicular from P on this line, and this distance, let me take here the point. Okay, let me take here P, M, and Q. This is S, we always take. This is A point here. So SA is equal to PM, because this strip is revolved around its asymptote. This is the asymptote. If I revolve this strip around this cube or solid figure, will be obtained. What is the volume of the solid figure we have to calculate? For that, this radius is required. Radius is Pm. Pm is equal to Sa. So radius of that circle, which will be formed by this strip around the asymptote. If we revolve that around the asymptote, a circle will be formed, and that area of circle is, we know that pi r square. Area is pi r square into depth is this delta y. This depth is delta y. Okay, so let P, M, and Q is an elementary strip. Let me write here. Is an elementary strip. Is an elementary strip. Okay, and drop a perpendicular PS perpendicular to OA. This PS is perpendicular to OA. This is right angle. Okay, so that means now therefore PM is equal to SA. What is SA here? Now SA is equal to, therefore SA is equal to OA minus OS. That means OA is A minus X, because X coordinate of P is X by, let me take coordinates of X, sorry, P. Coordinates of P is X and Y. Coordinates of Q are X plus delta X, Y plus delta Y. That we take always. Okay, so this is A minus X. Therefore, the volume of this strip revolve around this, a solid obtained by revolving this strip around the asymptote will be, so the volume of the solid, okay, solid obtained after revolving the elementary strip. The strip, let me write, a strip around the asymptote. Around the asymptote will be pi into A minus X whole square. This is the radius here, pi r square into delta y. This is the volume into delta y. This is the volume of that. Okay, that strip or that circular strip. This strip is moved around this solid obtained by this in the form of a circular strip. Okay, that will be the volume. If I apply this to the whole this, okay, the solid which is obtained after revolving this curve around this asymptote, that will be limits minus infinity to plus infinity, and we will write here this. So let me convert that into this value. So what is that value? Therefore, volume of the curve of the solid generated by revolution, let me write revolution of curve around its asymptote. Is equal to, okay, so let me write that, will be equal to sine of integration minus infinity to plus infinity, minus infinity to plus infinity, this is minus infinity, y equal to, and here y equal to plus infinity. Okay, so this is pi into A minus X whole square into dy now. Okay, so this is the complete volume. Now if I convert X into, from this equation, what is X from there? Okay, and if I substitute the value of X from that equation, so let me write that, solve this for X. Here we have A into y square minus X into y square is equal to A square into X. Now X is this common. Take this to that side. So we will get A y square equal to okay, A what is this? A by square equal to a square plus y square into x. Therefore x equal to this. Therefore x equal to, this implies that x equal to, from this equation, a by square divided by a square plus y square. Simple. If I substitute this value of x in this equation, simply this is the value of x here. Now let me substitute this here. So substituting this value, now then limit will be same. This is twice 0 to infinity. Let me write 0 to infinity twice, because non-simplicity plus simplicity, it is twice 0 to infinity, no problem. Pi into, let me write a minus x value is this. This is a by square upon a square. Is it yeah, a into y square. Alright, this is a into y square upon a square plus y square. This is a square plus y square. A minus is whole square into dy. Now this is converted into y. Okay, now let me further solve it. So what does it give? Okay, it gives, what does it give us? Let me write here. It will give us v is equal to sine of integration 2 pi, this pi I have taken outside, 2 pi, this is twice pi, 0 to infinity, within the bracket now, a minus this, let me solve it. It will be aq here. Okay, so this will be aq, if I multiply by a, taking LCM, so aq, it will be plus, it will be then a into y square minus a y square divided by a square plus y square, alright, into dy. These two steps are cancelled out. It is constant value a q upon this, alright. Now let me write it further. Therefore, this is nothing but 2 pi 0 to infinity. Here it is aq whole square is this. I'm sorry, it was whole square of that. aq whole square, that means a6 in the numerator, divided by, this is a square plus y square whole square, right, 26 into dy. So this was whole square, a minus x whole square. This whole square is there. This whole square is aq whole cube, that means a6. Now if I take a6 outside, this is 2 pi a6 outside, 0 to infinity. Now this is 1 upon a square plus y square whole square into dy. Now let me substitute something. Now putting here, what we have to put here, y is equal to a into tan theta. No problem. If I put y equal to a tan theta, then dy is equal to a into secant square theta. And the limits, what are the limits here? And for limits, if I put y equal to infinity, then tan theta equal to pi by 2. Okay, tan theta equal to tan pi by 2 or theta equal to pi by 2. So at y equal to infinity, theta equal to pi by 2, because tan 90 is infinity. Here it is infinity by infinity. Infinity upon a is infinity. So tan theta is infinity for tan pi by 2. Theta equal to pi by 2. Simple. At 0, when y is 0, tan theta 0 is for 0. So theta equal to 0 at y equal to 0. At y equal to 0, lower limit, theta is also 0. Okay, now let me substitute these values. This let me use that. Okay, so now let me put it here. So finally, v is equal to 2 pi a6. This is now within this 0 to pi by 2 now, because now 0 to infinity is converted into 0 to pi by 2, because we have taken y is equal to a tan theta. So it will be, now dy is a sec square theta in the numerator, a sec square theta d theta. Try to understand. Dy is a into sec square theta d theta. This is d theta, sorry. Alright, now divided by a square plus y square, that means a square we will take common, so a4 will come out. It will be 1 plus tan square theta inside whole square. Okay, that means this is secant square theta, secant 4 theta, 1 sec square theta cancelled out, so this 1 sec means cos square theta in the numerator. That will be now solved. Finally, let me solve it further. This is 2 pi a6. Now it is a4 and this a6 is a2, and okay, 0 to pi by 2 sec square theta. This a, so this 1a is also there. It is aq now. This a will also come out. I'm sorry, so this is a. It will be aq now. And this is sec square theta into d theta divided by sec 4 theta. Why 4? Sec square theta from inside the bracket. 1 plus tan square theta is sec square theta. Sec square theta whole square, that means sec 4 theta. 1 sec square theta is cancelled out. So it is nothing but 2 pi into a cube. A into a square is a cube. Okay, this is 0 to pi by 2. Now it is 1 upon cos square sec square theta into d theta. This 2 pi into a cube, 0 to pi by 2 into this is cos square theta d theta. Now this is for, by reduction formula, we know that when cos square theta is there, it will be converted into 2 pi into a cube into 1 upon 2 into pi by 2. This 1 2 cancelled out. It is nothing but pi square 1 upon 2 pi square into a cube into pi square. It is the same value, I think, 1.2 pi square into a cube. That's right. Hence proved. The same result has been obtained. Hence proved. So 1.2 pi square into a cube, 1.2 pi square into a cube. It had to be shown that the volume of this curve around its asymptotes, if we move, formed by this revolution of this curve around its asymptotes, what is the volume of that? That volume is 1.2 pi square into a cube. This we have to prove. Hence it is proved. Question 7 complete. So question number 7 is complete now. Okay, so hence it is proved. That is the process here. I'm just talking about the process of solving these kind of questions. Now let me talk about question number 8. Now question number 8 is of what type? Let me now check it. Question 8 says that the part of the parabola y is equal to 4ax cut off by the lattice rectum revolved about the tangent at the vertex and the volume of the reel thus generate. Okay, so this is the question number 8. Now it says that parabola is, this is the parabola y square equal to 4ax. Parabola is y square equal to 4ax. Let me change it. Y square equal to 4ax. Okay, now it says that its lattice rectum, let me take this is focus S. Its rectum is this. This is, let me take L, S, L dash. Its rectum, this is point A0 at S focus. Lattice rectum is passing through the this. Now it says that this is X axis here, X dash, and this is Y and Y dash axis. Now what does it say? It said that part of the parabola y square equal to 4ax, y square equal to 4ax. Okay, y square equal to 4ax cut off by the lattice rectum. This is the lattice rectum. It cuts off this parabola. Now it says that this parabola, this part of this parabola, is revolved around its revolved about the tangent at the vertex. And the tangent at vertex is this y-axis. Now if I revolve this parabola around this, it will be formed like this. I'm sorry. The same type of curve here will be formed. Okay, so this is the curve here. Let me take this as this point. Okay, so this kind of reel is formed. Now this is the reel here. This reel, this reel, this reel. Now for this, what are the points here of L? L coordinates are, this is A, x coordinate, twice A is the y coordinate. We know that y equal to 4A. If I put x equal to A, then y will be twice A plus minus twice A. And here the points are A and minus 2A, lower limit. Okay, so what is the reel here? This is the reel. If I have to find out, this is the P point here, let me take on the curve. This is P, Q, this is N. Okay, let me take M, no problem. Any point we can take. This is the strip here. Now it says that this strip is revolved around this tangent. Tangent is y-axis here, because at the vertex, what is the tangent of the parabola? This y-axis is the tangent to the parabola at its vertex. This is the vertex. Okay, so around the y-axis, this cut by latus rectum is revolved around. So this we have to find out. This reel is now generated. Now it says about the tangent at the vertex. Find the volume of the reel thus generated. So the reel is this and this also. This whole. These two portions, volume of these two portions we have to find out. If I find out, if I put the limits from L dash, this L dash to L, that means minus 2A to plus A, then this area both will be involved, both will be included. Okay, so that we can do, or we can write twice 0 to, this is here y is 0, here y is twice A. So this is y coordinate we have to take, and this strip, volume of this will be what? That we have to find out. Okay, so that volume, for that volume we have to find out here. So what is the, this is delta y here, this is delta x here, delta y, this is delta y, and here this length is what? If I again draw perpendicular from P on x axis, coordinates of x is this is x and y here. Okay, so this is y here. So and this length, and then area of the curve will be, this is delta by x square into, this is x square into dy. So the x coordinate is this only, up to this point, only x coordinate. So x square into delta by pi x square into delta y is the volume of this. This is x coordinate from this point to this point. This length is total x, only this is x here. From origin to this point, let me take here P, okay, S we have taken, so this is T, let me take point T. So here OT is this length S, x square into dy. So what's the volume of this reel here? So volume of the reel, let me take this solution. We are taking here, what is the curve is here, parabola y is equal to 4ax. This is first equation. Second thing says the latus rectum. The latus rectum is the latus rectum LSL dash. LSL dash. This is the latus rectum. This is revolved around this section. This section is revolved around this tangent line. Which section is OL only? So this OL, or let me take here any point. OL, let me say C point here. So OLC is revolved around this. Similarly, this portion, if I take LOL dash, this section, okay, up to this, or just twice of this we will obtain, 2 times 0 to this limit. Or if I say that this is also revolved around this tangent line y-axis, so this is also included. So limit, if I take minus 2A to plus A, then this will also be included. Okay, this plus this we have to find out. The volume of the reel here, L dash, coordinates of L are let me write here coordinates of L are A and twice A that we have already taken. Therefore, y varies from minus 2A to y equal to 2A plus 2A for the whole curve. This real and this real. This is the real here. This whole section and this whole section. These two sections. So I have to take limits from minus 2A to plus 2A. Therefore, volume of the real, okay, generated by revolving OLCO around this and this also. Okay, so that twice we will take. If I take 0 to 2 element, here y is 0, here y is 2a, that can be done. Or if I take minus 2a to plus 2a, then twice is not required. Or you know that minus 2a to plus 2a is can be converted into 2 into 0 to 2a. That is simple. Okay, this around tangent at around y-axis. Let me take y-axis. Why y-axis? Because y-axis is the tangent at the parabola at the vertex. As y-axis is the tangent at vertex of the parabola. At the vertex of the parabola. Okay. So around this y-axis, we have to revolve this curve, and this curve is also revolved simultaneously. This area and this area, these two areas will be included. Okay, so that means the volume therefore v is equal to limits from minus 2a to plus 2a. This is y equal to minus 2 to plus 2. And here it is pi into x square into dy. Pi into x square into dy. Simple. What is x square? X can be taken from here. So this is nothing but, now I can write it as twice 0 to 2 is simple. Pi, let me take outside x square. X is here, y square upon 4a. Here y square equal to 4ax, or x equal to y square upon 4a. This is y square upon 4a. Therefore, x square is equal to y4 upon 16a square. So here I have to substitute value of x square. That is here y4 upon 16a square into dy. Can be simply integrated. Okay, no need of this. y4 is integrated. Let me integrate this. So therefore, v is equal to, this is 2 pi upon 16 a square. 2 pi upon 16 a square are taken outside. And here it will be integration of y4 is by 5 upon 5, 0 to 2. Why? Because this is with respect to y. Integration of y4 can be done by 5 upon y5, by 5 upon 5. So let me substitute. This is 1 upon or pi upon 8 a square. Here it will be twice of 5 has also come out. This 5 will come out. By 5 is twice a whole power 5. This is to be now complete by calculation. Let me calculate this whole. This answer v will be pi upon 40 into a square, this value 5 8 is 40, into this. This is 32, 2 raised to 5, 32 into a5, a square, and this a5 is a cube. Okay, and this is 32 pi upon 40. I'll just cancel out this, and this is a cube. It will give us 8 4 is 32, 8 5 is 40. It is 4 pi upon 5 into a cube. This is the answer here. Okay. Question number 8 here. No answer is not given. No problem. This is the answer here. 4 by 5 pi a cube. Now let me write this answer here. So answer of this question number 8 is 4 by 5 pi AQ. Okay, so question number 8, because let me write here, this is 4 pi AQ upon 5. This is the volume of the reel. This is the answer here. 4 pi AQ upon 5. Now let us take 9th question. So question number 9 is of what kind? Let me check. Question 9 says the area of the parabola y square equal to 4ax bounded by the lattice rectum, okay, revolved about the tangent at the vertex. Find the volume of the solid generated. Now try to understand what is this point. Now here the point is same, question number 9. Here the volume of the reel which we have just calculated will be subtracted from the volume of the cylinder. That is the remaining portion. I've just found this equation. This is 9. Question number 9 here. What does it say? Parabola is the same. Curve is the parabola y square equal to 4ax. Now try to understand. Y equal to 4ax here. So solution, let me find out. Now it says that the area of the parabola y square equal to 4ax. That area of the parabola we have to find out which area, bounded by the lattice rectum. Lattice rectum revolve about the tangent. Lattice rectum revolves about the tangent at the vertex. Find the volume of the solid generator. Now try to understand. This is the same parabola. We have taken this, and here also we took the shape of this, shadow of this. Now this is the parabola, reel of the parabola we just calculated, and this is the lattice rectum, and this lattice rectum is also obtained by revolving on this. Now what is the area we have to find out? It says that this reel is not calculated. Now this area and this area, this shaded portion and this shaded portion area is to be calculated. This is the area of the solid. That means area of the whole cylinder minus this reel area. Reel area is this. I have noted down here. This is in question number 8. We found this area of reel. This area of the reel we have already calculated.